Let's do few more questions, then we will be doing the converse part. I mean the converse of the proof. We will be proving it, but before that, let's solve few questions. So question number 2. After, okay, from here, question number 2, question number 3, you will find that all are almost same. Yeah, we need to discuss it because for the very first time you are going to do this type of question. So yeah, let's do it. Question number 2 says E and F are point on the side PQ and PR. Figure is not given. We need to draw the figure. Last day we were doing this one, right? Question number 2 we were doing, and I told you that you need to check whether EF is parallel to QR or not by converse of basic proportionality theorem, right? Right? We had already discussed question number 2, yes or no?
Yes, ma'am.
Okay, let's do question number 3. In figure 6.18, so this figure is for question number 3. If LM is parallel to CB, I'm highlighting LM and CB. Let's see it. LM is parallel to CB. The moment you will find that something parallel is given, that means you need to search a triangle now, so that you can use basic proportionality theorem. So if a ratio will be given, then you need to search a triangle. Okay, so that you can see whether you can use basic proportionality theorem or maybe the converse of basic proportionality theorem. If parallel condition is given, so of course, okay, these two lines are parallel, and we are here only. I will take a pause and I am asking you that which triangle can be taken so that I can say that one of the side is parallel to one of the line. Which triangle can be taken over here? Yes. Which triangle can be taken? Can you see this two green color line?
Yes, ma'am.
On the
Yes,
basis
ma'am.
of this two green color line, which triangle we can take? So that we will have this type of condition that there is a triangle and there is a line DE parallel to the side BC. This type of condition, how you will be getting which triangle to take from here?
Ma'am, triangle ABC and ADC.
Yes, we will be taking triangle ABC. Focus ABC. At first, we will be taking ABC. Then only we can say that one of the side of this triangle BC is parallel to LM. Okay, so basic proportionality theorem, again, I am reminding you, it says that, okay, there is a line parallel to one of the side, parallel to one side of a triangle, okay, intersecting the other two side at two distinct point, then the other two side will get divided in the same ratio, and it looks like the same. Okay, it looks like same that we are having a triangle like this, and parallel to one of the side we are having a line which is parallel to one of the side of a triangle, intersecting the other two side at two distinct point L and M, then the other two side will get divided in the same ratio. So the moment we are noticing this one, LM is parallel to CB, we will say that in triangle ABC, LM is parallel to CB. That means we can use basic proportionality theorem. What? We can write AL by LC must be equal to AM by MB. Getting it? Is it making sense to all of you?
Yes, ma'am.
Ma'am, but how do you know it has the same ratio?
How do we know?
The ratios are same.
So in the last class, when we were discussing the like whole class, we were discussing one proof, and what the proof said, what the proof says, that if you are having a triangle, just a moment. If you are having a triangle, and in that triangle, if you are having a line parallel to one of the side of a triangle, if there is a line parallel to one side of a triangle and that line is intersecting the other two side of a triangle at two distinct point, then the ratio between other two side will be same. That means AD by BD, that will be equals to AE by EC. And we have proved also this ratio, we have proved in the last class. Just a moment, no? Yeah. This ratio we have proved in the last class with the help of, just a moment.
Oh, so ma'am, so it's parallel, so the ratios must be same.
Of course, basic proportionality theorem, what we did for the whole class. We were having a triangle and we were just knowing that there is a line parallel to one side of a triangle. Okay, and then the ratio will be same. So with the help of area of the triangle, area of that triangle, area of this triangle, area of that triangle, area of this triangle, we created the ratio of the areas. Then we said that the areas are equal, hence we can compare, hence the ratio will be same. That's what we did the proof in the last class, right? Right.
Yes, ma'am.
So it's not just a proof, it's an application, that whenever you will have such a triangle where one of the one line you will have, just a moment, let me show you all the three cases so that you will understand. A triangle, okay, you are having a line parallel to one side of a triangle. Maybe your line looks like this, parallel to one side of a triangle. Okay, so this time this line DE is parallel to AC. This time this line DE is parallel to AC, and the moment you realize that it is parallel, then you will write the ratio will also be same. Okay, that BE by EA will be equals to BD by DC. That's what basic proportionality theorem says. Okay. If you are having a triangle, and in that triangle, if you are having a line parallel to any one of the side of a triangle. Okay. So if you are having a triangle PQR, and if you are having a line ST parallel to PQ, okay, and this ST you are having in such a way that it is touching the other two side of a triangle. ST is parallel to one side of a triangle and intersecting the other two side of a triangle. If that is the case, then you can write it will, this line will divide the other two side in the same ratio. That means RS to SP is equals to RT to TQ. Getting it? Getting it?
Yes, ma'am.
Okay, again, let's read the basic proportionality theorem, because apart from understanding the proof, if you are able to do the proof, great. But you need to understand this theorem. We will be using it in almost every question, that if a line is parallel to one side of a triangle to intersect the other two side at distinct points, the other two side are divided in the same ratio. If this, then this. If line is parallel, then the other two side divided in the same ratio. If there is a line which is parallel to one side intersecting the other two side at two distinct points, then your other two side will get divided in the same ratio. Doesn't, it is not necessary that the parallel line must be parallel to this horizontal one. No, it's not mandatory. Your line can be parallel to any one of the side of a triangle. It can be parallel like this, it can be parallel like this. Okay, you just need to realize the ratio will be same. Which ratio? This, let me take another color. This one to this one will be same as that one to that one, or maybe this one this one to this one. Wait, no, why it is happening like this? This one to this one will be equals to the other one, the downward one. Are you getting it, everyone? Getting it? Yes or no?
Yes, ma'am.
Is it clear now, Inan?
Yes, ma'am.
Okay. So on the basis of I'm sharing the screen again. And yeah, let me explain you the converse also just now. You can see the screen, right? Right?
Yes, ma'am.
Let me explain the converse of this theorem also. So if parallel, then ratio same. That is basic proportionality theorem. Converse says that if the ratio is same, if in case you are having a triangle and you are saying that there is a line which is dividing your, suppose the name of the triangle is RST and this is the line MN, and in case this line is parallel, not parallel, you don't know anything, you are just having a triangle RST and you are having a random line MN, a random line MN you are having. Okay, such that the ratio is same. In your question it is given that the ratio is same, or you are realizing that the ratio is same. Which ratio? You are finding that Tm by Mr, that is equals to Tn by Ns. If this is happening, if this one, then you have to say that of course this Mn and Rs are parallel line. Are you getting it? This is converse of the same theorem, just the reverse way. That if the line is parallel, then the ratio will be same. You can take by yourself that the ratio are same. And in case in the question it is given that the ratio are same, then by yourself you can take that the line will be parallel. Are you getting it? And in mathematics, you are not doing it for the very first time. Okay, you have always used the identities and formula in this manner only, that if a plus b whole square formula is a square plus twice ab plus b square. So in case you a plus b square, suppose 3p plus 5q square is there, we will be expanding it by using the formula or in case if we are having maybe just y square plus 2y plus 1, we can write the formula that it is nothing but y plus 1 whole square. Yes or no? Yes or no?
Yes, ma'am.
So both way we are
Yes,
using
ma'am.
the formula, right? When the left hand side is given somewhere in the question, quickly you are using the right hand side. And somewhere in the question, if you are finding the right hand side, quickly you are using the left hand side of the formula. And you know the formula doesn't mean that left to right only we need to use. We can also use right to left. Similarly, I am telling you, if parallel, then the ratio same. And if the ratio same, then the lines are parallel. Making sense? Getting it, everyone?
Yes, ma'am.
Okay, let's move and let's focus on the question. So here it was written that parallel. The moment we realize parallel, we return the ratio same. Yeah, ratio, you need to write it properly. You cannot mix and match everything. Mixing means just write it properly. Properly means what? Properly means if you and LC in the denominator, see the ratio. We have written AL in the numerator and LC in the denominator. See the figure, AL and LC. This way you are writing the ratio. Other side also you will be writing the ratio in this manner only. Okay, starting from A, and it will be AM MB. Getting it? Getting it?
Yes, ma'am.
Okay, so just write it in a sequence manner. AL to LC, similarly AM to BM. Clear? Now the next. And LN is parallel to CD. That too is written in the question. LN is parallel to CD. I am rubbing everything in this figure. And please check. LN is parallel to CD. LN is parallel to CD. LN line is parallel to CD. Just from this condition, you have to identify the condition. Okay, a quadrilateral will be given to you, a airplane like figure will be given to you, any random shape will be given to you, a trapezium type of structure will be given to you. You have to identify your triangle from there. How? When the parallel lines are given from that particular, okay, ln is parallel to CD written over here. Are you getting which triangle we can take from here, from this whole structure, which triangle to pick? Please tell me.
ACD.
AC, triangle ACD, we will be taking ACD, and we will say that since ln is parallel to CD, okay, in triangle ACD, ln is parallel to CD, then we can write the ratio. We can write the ratio. Which ratio? AN is to ND is equals to AL is to. How simple it is. In bracket, you are writing by basic proportionality theorem. What we have done? We have not done anything over here. Parallel was given. We have written the ratio. Another parallel condition we saw. We realized the triangle. Finding the triangle from the figure was not okay that difficult. It was really simple. We just realized which triangle to take. We have written the ratio. Now just compare both the ratio. See carefully both the ratio. You have written, you have written this one AL to LC, AM to MB, and you have written this one ANND, ALLC. See ALLC, are you able to match it? Can you see it carefully that ALLC is here also, the blue one, AL to LC, it's present over here also and it's present over here also. Can you see that, everyone?
Yes, ma'am.
And if you can see that, we can do the comparison of both the equation. What are we going to do? Comparing 1 and 2. After doing the comparison, we can say that AM to MB is equals to AN to ND. Since the blue one and blue one is same, then we are saying that the green and the brown one will also be same. And we are done with the proof. You can check it in the original question. We are done with the proof. It's that simple. All the questions over here are like that only. Parallel condition will be given. You have to just carefully, you have to examine which triangle to take, write the ratio, and you are done. Can you see whatever we were supposed to prove, we are done with the proof? Steps are clear to everyone?
Yes, ma'am.
Okay, let's do the next one. Anyone having any doubt? See, you should note down these things in your copy. Okay, because you won't be able to just keep all these concepts, all logics in your mind. So of course you need to note it down quickly. Okay, if not, just write the hint. If not completely, then you can also note down the hint later on, but after the class you are doing it properly. if you are not attending the class like this, you are not, no, you are not writing anything over here, you are just coming, joining and leaving, you are not doing anything, then it's of no use, let me tell you. Okay, you should you should always take a note from here. After the class, just that day only or the next day, you have to just go through everything. You have to open the exercise, you have to do the questions which we have discussed over here by yourself. I will let you know at the end of every class that today what you will be able to do. And before the next class, once you are joining the next class, before that you are just going through everything, then only you are joining. If this way you are learning things, then only your mind will be able to retain the data, otherwise you won't be able to do anything. Always you will feel that you are understanding here, still your performance is not improving. So we are done with number 3. Number 4. Number 4, in the figure 6.19, when the figure is given, half of the work is done for you. Okay, more than half of the work. In the figure 6.19, parallel. Parallel. Parallel means I will start searching the triangle first. DE, where is DE? Let me highlight it. And AC. Who will say which triangle to take? On the basis of this two parallel line, which triangle can I take? So that, okay, this DE must be parallel to one of the side of a triangle. Guess which triangle can be taken over here? Think about it. We need to pick such a triangle so that either DE or AC must be one of the side of triangle. You need to pick a triangle where you are having a line parallel to one of the side of a triangle. You need to pick such a triangle where this extra line, okay, this extra line, whatever be the name, RSST, whatever be the name, this must be parallel to one of the side of a triangle. Okay, your RS, in this example, RS must be parallel to BC, or maybe RS must be parallel to AB, or maybe RS must be parallel to AC. That must be the case, then only we will be able to write the ratios and all. Are you getting it? It can be like this, or it can be like this. That type of triangle you need to search. I have highlighted already DE and AC. DE and AC I have highlighted. You have to name the triangle. Who will name? Can I say triangle ABC? Straightforward ABC. Yes or no? ABC. Why ABC? Because you can see so many things over here. Why ABC? Because AC side is included. Okay, that AC is parallel to DE, and the condition is DE must touch the other two side. DE must touch the other two side at two distinct points. Yes, it is touching the other two side. Can you see it?
Yes, ma'am.
Are you getting it?
Yes, ma'am.
Everyone. Okay, this is what we have to do only to identify the triangle properly. Yes, this type of figure will be there, or much more trickier than this one, confusing figure will be there, but you have to identify the triangle. How you will identify the triangle? You will just look the highlighted part, the blue one, AC is there, DE is there. Now we need a triangle where one of the side, okay, here AC is parallel to DE. AC is parallel to DE, so I'm just checking that DE and E, are touching which side? AB and BC. That means, can I take this triangle? Just that. And yes, we can take. Getting it? Is there any confusion over here while identifying the triangle? Rayan, Inan, Samia. Any confusion?
No, ma'am.
Okay.
No, ma'am.
DE is parallel to AC. We identified the triangle properly. Now we will be writing the ratio. What ratio? Write the ratio. Ratio means AD to DB by CE to BE. Either write like this or write like this, but write in a proper sequence. Sequence means you can write the ratio this way. If you are starting from B, so BD to DA is equals to BE to EC. You could also, okay, you could have written the same ratio as, you could have written the ratio as AD to DB by CE to EB. These two are exactly same thing. These two are exactly same thing. If x by y is 1 by 2, I am telling you x by y is 1 by 2. Then you can tell me that y by x is 2 by 1. And I will say, yeah, these two are same thing. Are you getting it?
Yes, ma'am.
Yes, Inan, is it clear? Rayan, is it clear?
Yes, ma'am.
Okay, so I am just telling you, write the ratio in a proper sequence. That means if you are starting from here, then this side also just start from here. Start from here. Okay, or maybe if you are starting from the bottom, that one you are taking at first. So here also on the other side, just take the bottom one, this side at first. That's what I am trying to tell you. Okay, just maintain the sequence properly. Okay, and yeah, the example is x by y ratio is 1 by 2. Even if you are getting y by x 2 by 1, you are getting the same thing. We have written the ratio. Okay, from the parallel condition, we identified the triangle property ratio properly. How you will write the step in your copy? You will write in triangle ABC. DE is parallel to AC. Therefore, the ratio, okay, this circle one, the ratio will be same. In bracket, by basic proportionality theorem. Clear? Now one more condition is given to you, and this time you will be telling me which triangle to pick from here. Okay, you can clearly see on the screen, this time it is given that DF. DF is parallel to AE. I am highlighting DF, I am highlighting AE, and you will name the triangle. Okay, DF is there and AE is there.
Ma'am, we should take the triangle AEB, right?
Yeah, we will be taking triangle AEB. When the parallel line will be given, no, you have to just see the bigger side, the bigger one. Okay, DF is there, AE is there. So just focus on AE, and take out the triangle. Are you getting? The triangle will be AEB, ABE, whatever, ABE, AEB, whatever. Getting it?
Yes, ma'am.
Okay, now write the ratio. Okay, just write the ratio that BD by AD is equals to BF by FE. Can you see BD, BD, DA, AD, same thing. So if this side is same, we can compare the ratio. It's that simple. Here triangle chapter is easier than the previous class triangle chapter. Are you realizing it? That BE by EC is equals to BF by FE. Are we supposed to prove that only? Let's check it. Let me write it. Comparing this two ratio, we are getting B by EC is equals to BF by FE. Okay. And just see the ratio. BF by FE equals to B by EC. Are we done with the proof? Are we done with the proof? Yes or no? Yes or no? If you are thinking no, we are not done, then I am telling you we are done. Okay, left hand side, right hand side can be here and there. Can you see that? Can you see that? Anyone having any doubt that why I'm telling the proof is done? It's not done. Anyone want to say that it's not done? Yes. Are you getting it, Afrin, Samia, Rayan, Inan?
Yes, ma'am.
Yes, ma'am.
No, you are not getting. See carefully. BF by FE, BF by FE, BE by EC, BE by EC. Are we done with the proof? Yes or no? Yes or no? Anyone having any doubt that we are still not done with the proof?
Oh, ma'am.
Are we done? Yes or no?
Yes,
Yes,
ma'am.
Afrin, are you getting it?
Yes.
Samya,
Yes, ma'am.
Rayan,
Yes, ma'am.
Inan. Okay,
Yes,
let me
ma'am.
write it properly. Okay, from here we can write the right side on the left side and the left side on the right side. Now we are done, right? Now we are done, right? Here the left hand side, okay, I have this LHS. From there I have written in the RHS, and RHS from here I have written in the LHS. Now we are done with the proof, right? How simple it is. How simple it is. Just the parallel line condition is given, and what you are doing, just identifying the triangle. And there is a theorem to help you, that use the theorem and you are done. Just you have to do the comparison of the both the equation. No solving, nothing. Okay, it's really simple, really easy, and the same thing we'll be doing in the next question. Same thing, exactly same thing we are going to do in the next question. You can see the next question over here is in figure 6.20. DE is parallel to OQ. Okay, again I am going to highlight this DE and OQ for you. DE and OQ. DE and OQ. And I told you the bigger side will always help you identifying the triangle properly. Okay, DEOQ. DEOQ. Just focus. Which triangle to take on the basis of DE and OQ? Even though the figure looks like a three-dimensional figure to you, please don't worry. Just take a triangle. Triangle is a 2D shape. Okay, from a A4 sheet paper, you can just cut down a triangle, and that type of triangle we are talking about, a flat surface. A flat surface on which I will pour water and it will not be able to retain the water. That is our two-dimensional shape. So even though the figure looks like a 3D shape, you have to think about a triangle which is 2D. Okay, a flat triangle just. Now tell me which triangle to take. On the basis of DE is parallel to OQ, which triangle to pick from here? I'm talking about question number 5.
And triangle PQO.
Just by looking at this OQ, are you thinking to take triangle POQ? Yes or no?
Yes, ma'am.
Yes, everyone getting the same. Are you thinking about taking triangle POQ? But the basic proportionality theorem says that smaller line must touch the other two sides. So yeah, it is touching. Yes or no? We can use basic proportionality theorem over here. How easy is that? Our triangle is just like this. Okay, a pyramid type of shape you are having, but your triangle is here, just this one. Okay, don't see the middle one, don't see this one, don't see the below one. No, you just have to see your this triangle. Okay, can you see it clearly? Getting it?
Yes, ma'am.
Okay, POQ triangle you are going to take. POQ triangle you are going to pick. There you will write that DE is parallel to the side OQ. What ratio you can write? Very easy. PE by EQ is equals to PD by DO. One of the ratio already we have created. Now let's see the other ratio, other parallel condition. Okay, DF is parallel to OR. I'm going to rub everything. DF, DF, and OR. Now tell me the name of the triangle. Please tell me the name of the triangle. Tell me the name of the triangle. Who will say? Yes, who will say which triangle to pick from here? Where DF is parallel to OR. Not getting? Let me show you. From this A4 sheet paper, I'll cut 4 triangles, 5 triangles. Okay, we are going to make a pyramidical, this pyramid type of shape. Okay, 4 just skeleton triangle or equilateral triangle, whatever be the triangle, 4 to 5 triangle I'll be cutting from this page. One of the triangle I'll put at the bottom. One of the triangle I'll put it over here. One of the triangle I'll keep over here. One of the triangle I'll keep over here. And one of the triangle I'll keep over here. Yeah, that became a 3D shape. But I'm just telling you which triangle to pick from here. Okay, on the basis of DF is parallel to OR. Here you are able to see 4 5 triangles, so many things parallelly, but clearly I'm just talking about this triangle, this one, bottom one, which one? Can you see? Let me give you more clarity about this figure, because you don't have to get confused with this figure every time in mathematics. You are going to see such figure, but this should not confuse you. Your concept should be clear in such a way that these 3D shapes and all, we are not discussing about this. We are not finding the volume area of this three-dimensional shape. Yeah, here I can see a triangle OQR. Can you see a triangle OQR, the bottom one? Can you see? Can you
Yes,
see
ma'am.
another triangle over here, that is PQO, which we have taken already? And can you see the other triangle over here, that is POR? Can you see that?
Yes, ma'am.
And can you see the bottom, the middle one? There is a triangle in the middle. Can you see that? This triangle, that is DEF.
Yes, ma'am.
So clearly there are more. There are more triangle, but these are some of the triangle which we can see from here, right? Clearly we can see. I'm talking about this type of triangle only. Just name the triangle. No, it is given that DF is parallel to OR. Again, I'm going to highlight DF and OR, and again I will be asking you only which triangle to take. Which triangle to take on the basis of DF is parallel to OR.
POR. Triangle POR.
First, we'll be taking triangle POR. Yes or no? Is it a triangle? Of course it is a triangle. Can you see that? Now that particular line DF is parallel to one of the side of a triangle OR and is touching the other two side at two distinct point D and F. Can you see that? We can write the ratio, that is PD to DO is equals to PF to FR. Yes or no? Any confusion so far? Now see both the ratio. Just see carefully both the ratio. Are we getting something by doing comparison? First tell me till here it is clear or not. Afrin, is it clear? Afrin, is it clear?
Yes.
Rayan, is it clear?
Yes, ma'am.
Samya, is it clear?
Yes, ma'am.
Inan, is it clear?
Yes, ma'am.
So if we have written both the ratios, okay, same thing we are doing in each and every question. We have written both the ratio and from there, what are we getting? So this PD, wait, this PD to DO, this one and this one is already same. We can do comparison of both the ratio. By doing the comparison of both the ratio, what are we going to get? We are going to get PE by EQ is equals to PF by FR. Yes or no? Right? But that we don't have to prove over here. That you don't have to prove over here. Just see carefully in the figure. You have to prove that EF is parallel to QR. So we started the class from here. Okay, the moment Inan joined, he said that why we are taking parallel, then the ratio are same. And then I have explained everything from the beginning that when parallel will be given, then basic proportionality theorem says that the ratio will be same. But in case ratio will be given, the converse of the basic proportionality theorem says that the lines will be parallel. In case ratio are same, then there like we are going to get two lines which are parallel to each other. Just the reverse, just the converse of basic proportionality theorem. So if PE and EQ, let me highlight the ratio. PE, the ratio which we got from equation number 1 and 2. This is equation 1, this is equation 2, and by comparing 1 and 2, we got the circle 1. We got the circle 1. Every time we were done till here, because this is what we were supposed to prove in all the previous question, but not here. But not here. Here it says that PE by EQ. Okay, we got PE by EQ is equals to PF by FR. PF by FR. Then just from here, can I say that we can talk about triangle P, the complete triangle PQR? Yes or no? In complete triangle PQR, see carefully. If the ratio is same, if the ratio is same, then does it look like that we can talk about in triangle PQR, if the ratio is same, then EF must be parallel to QR? Yes or no? By converse of basic proportionality theorem, can you see that? Just draw the triangle separately. Compare the ratio PE by EQ, PF by FR. Can we use converse of basic proportionality theorem? Can we? And can we say that EF must be parallel to QR since the ratio is same? By converse of basic proportionality theorem? Yes or no?
Yes, ma'am.
And that's what we are supposed to prove over here. That prove that EF is parallel to QR. So the ratio which you have obtained by doing the comparison, that ratio is helping you. saying that EF is parallel to QR. But yeah, in bracket you need to write that you are telling this by using converse of basic proportionality theorem. Is it clear to all of you? Again, I'm repeating, this triangle chapter is much more easier than the previous class triangle chapter, where for the very first time you learn congruency, and here every time we are doing the same thing, right? Right?